Okay, what I would like you to do is start working through this worksheet. They ask questions about the figures, and when you get to the first symbol of a key, you're going to hit pause here, and when you get to that first symbol of a key, we'll discuss number 5. All right, so go ahead and do your thing. Okay, so we found in the discussion several terms. First of all, what does solute mean? So we're going to define that as well as concentrated and dilute. Solute is the thing that is dissolved. And solvent is what's dissolved in. So if you look back at the pictures on the first page, the solute is what the spoon is putting in. The solvent is the liquid in there. And you can see by looking at the particles, the second lemonade solution is much more concentrated than the first. It has more solute particles. That's the other definition we're looking for. Concentrated and dilute. And concentrated solution is a solution that has a lot of solute particles, and the dilute solution has less. So our question for number 5 now is, do these terms provide specific information? And the answer is no. They are relative, because what is concentrated in one situation may be very diluted in the next. Think about if you're making Kool-Aid and you put twice as much Kool-Aid in, and so that's going to be very concentrated. So the next time you make Kool-Aid, you make it in a regular batch, and then you run out, so you make another one and you use half the Kool-Aid and all the water. That's going to be very dilute. The other will be more concentrated, but not as concentrated as the first one. All right, your next set of pictures, the worksheet is asking about these pictures. So let's talk about these pictures. It shows you the first 3, 4, and 5 are all considered concentrated. Number 7, question 7 says, what does the M stand for? The capital M. Okay, and hopefully you can find it on this page. You're then going to be asked to calculate the ratio of the moles of solute to the volume, or liters. All right, well, it has come to my attention that we do not have any audio, so I'm dubbing this in, so it may not make sense. The next step is to find the molarity, which is the moles of solute divided by the liters of solution. Okay, you can take 0.18 mole copper 2 chloride divided by 0.06 liters of the solution and calculate molarity for that first number 3 beaker there. The same thing for beaker number 4, or actually any of the beakers. Take the number of moles divided by the liters. That will give you molarity. And each one of these is a ratio, moles per liter. So it's like when you're in math class and you're talking about a rate. Moles per liter, miles per hour, so on and so forth. Okay, number 9 asks you to write a formula. Molarity is equal to the moles of solute divided by the liters of solution. And now we can watch me write it out. And it's kind of funny because I'm talking, but I'm not synced with my picture, am I? Okay, so the next question says, what kind of solution will have a bigger molarity concentration? And then questions about the molar solutions on the previous page. Question 12, explain how beaker 5 with fewer moles of glucose can have the same molarity as beaker 4. So you need to look at that. How is 5 and 4 different, but still the same? And Okay, it looks like now we've gone on to the next page, which is the top of page 5. Calculate the molarity of a solution containing 1.5 moles of sodium chloride in 1/2 liter of solution. So I'm going to show you how to set that up there. And you guys can do the math. Question 15 is also having you calculate molarity by taking moles per liters. And that would be for an acetic acid solution. Question 16 gives you a 1/2 mole potassium chloride solution, and it gives you grams of potassium chloride in a solution. So the question, does 74.55 grams per 2,000 milliliters give you the correct molarity? And the answer is no. All right, you're going to get a different molarity. What you have to do first is change grams to moles, and we already know how to do that. Grams divided by molar mass. And you need to change milliliters to liters. To do that, you would take 2,000 milliliters and divide by 1,000 milliliters in 1 mole. Okay, so go ahead and do those calculations. All right, so for question number 18, what you want to do is flip back to the pages, page 3, the diagrams, and you're going to want to figure out the molarity by drawing in dots to represent the particles in that circle. Back page is extension questions. All of these are things you should be able to put together based on what you have done and the pictures that you have in your packet. So I'm hoping you guys get this finished, and we will go over it on Tuesday so we can blow through some molarity this week and try and catch up. Thank you very much. All right, so I just cut a little bit of the video out because I have no idea what I was saying and I was feeling really stupid. So where we are now, we're back on number 16. We're going to start to calculate molarity. First, we have to change grams of potassium chloride to moles of potassium chloride. So right now I'm looking up the molar mass of potassium chloride. It happens to be 74.55 grams per mole. So I'm going to take 74.55 grams divided by 74.55 grams per mole, which gives us, of course, 1 mole. All right, then we'll take that divided by 2,000 milliliters, which is the same as 2 liters. 1 mole divided by 2 liters gives us a molarity of 0.5 moles per liter. The units are a fraction, moles per liter, or you can use the capital M, which means the same thing. All right, so go ahead and work through the next one, and I am going to jump forward and see where we'll go next.